Okay, I'm going to look at the problem number 27. First, find the limit as x approaches 2. Okay. So this is a question. Question number 7. Find the limit as x approaches 2 from the positive side, e to the 3 over 2 minus x. Okay. All right. So first of all, we needed to know that the limit. Okay, we should remember. We should know the limit as the x approaches negative infinity, e to the x. Okay, that is going to be 0. The limit x approaches positive infinity, e to the x should be positive infinity. So that's what we know from the graph. Okay, so for limits, you can also use substitution. Okay, so you let u to be 3 over 2 minus x. Okay, and first you find the limit as x approaches 2 from positive side. What is that limit? That limit, I see, look at this, okay? When x approaches 2 from positive side, so then x approaches 2 from positive side implies two things. X is greater than 2. Then x minus 2 is positive, right? So, right? But yeah, so x is greater than 2. Then the second part is x minus 2 approaches 0. Approaches 0 from positive side. Okay, so here's 2 minus x. Okay, 2 minus x means x minus 2. 2 minus x approaches from negative side. So from here you can tell that the quotient is the denominator getting smaller and smaller. Okay, the denominator is always negative. The quotient will be getting negative a lot, going to negative infinity. So the answer will be just negative infinity. Okay, so that's it. And then then the limit as x approaches 2 from positive side, e to the 3 over 2 minus x is going to be limit. It changes the variable, and u approaches negative infinity. Then it's clear that it's going to be 0. All right, so that's the first problem. Now I can also talk about another problem. So do we have another? Yeah. Whoa, this is pretty complicated. Okay, so this is a story problem, right? 79. 79 is a story problem that this is about the cost function, I guess. Yeah. The area measure the mg per millimeters. Yeah. This is just ask you to find out the maximum value, okay, of that function. So maximum value of this function, I think we did a similar example here. This is a, I just, yeah. Okay, let me try. My page does not move up. Freeze. Okay, let's see. Oh, finally it's moving. I was trying to move this page up and down. Okay. All right, so the second question is just look at the function c over t, and this is 1.35 e t there, e to the negative 2.802. Okay, so this function is defined. This function is defined for t greater than 0, less than infinity. and we want to find out the minimum value, maximum value or minimum value. Okay, so look at this function. Okay, look at this function. Think about that. When t approaches 0 from positive side, this function is going to be 0, right? The limit, because the second part is approaching e to the 0. The first part approaches, t approaches 0, 0 times 1 is 0. And then as t approach the infinity, okay, c over t is also going to be 0. You know why? Because a function, look at this, right? This function here is going to be 1.35t, but the denominator is e to the 2.802t. So the denominator grows exponentially, the numerator just linear. So the quotient is going to be approaches 0. Okay, so that's why. Then if you look at in the between on the whole line, the function is positive. So that means if we draw the graph, it looks like that. Maybe there are a couple of bumps up, between them. So somewhere there should have maximum value, right? To find the maximum value. So all you have to do is just find the critical number, find the derivative of the function 1.35, and the t is gone, and the negative 2.802t. Then you differentiate the second part, it's negative 1.35, and 2.802, and this te to the negative 2.8. Okay, when you differentiate. So if you set this to be 0, what is left? The common factor should be gone, right? And this number is also should be gone. So it's only 1 minus 2.802t equals 0. Okay. Yeah. All right. So t is going to be 1 over 2.802. So there's only one critical number, and the function must have maximum value at that number. Okay. The function must have maximum value. So the maximum value, the absolute maximum value is c of that number. You see, I did not use a calculator here, right? So it's going to be 1.35. T is going to be an e negative 2.802, and then 1 over, right, 2.802. So those two canceled out. The answer is just e to the negative 1. Okay, so you can write in this form the exact value is e. That's it. E to the negative will go to the denominator. So this is a maximum, absolute maximum value. That's it for that particular problem. Okay. All right. Now, today we're going to talk about logarithm. How do we define the logarithm function? Okay. Remember, the logarithm function, we got in the last class, we already know that we get natural log function in some way. Okay, how do you do that, right? We find out the derivative a to the x is going to be a to the x and the L over a. Okay, then that's the first step, right? Then we find out, we introduce the number of e, right? E should be equal 1. Then we get e to the x equals e to the x, okay? The derivative. Then we notice that we can define, we find out L of e to the a is going to be a. So we believe that this L this L is going to be the L of a is the inverse function to, yeah. So this is going to be is the inverse function is a inverse of e to the a, right? So that means we're going to denote L of a by natural log of a. That's how do we get that? Okay, we got the natural log of function in this way. Okay, so that's the whole procedure. Yeah, step by step. You know which one first, right? The second, third. Okay, that's how it goes. And today I'm going to just define the log function as the inverse function of an exponential function. Here's the definition. Okay, so a is going to be positive, a is not going to be 1. Okay, and we know that the function is either decreasing function or the increasing function, exponential function. Okay, then this one has an inverse. Okay, because this is a monotonic function. Okay, either increasing or decreasing depends on the value of a. Okay, this one has an inverse. Okay, has an inverse. So I should say this is a decreasing function or increasing function depends on depends on the value of a. So okay, so is increasing. Okay, if you look at the picture, it looks like that when a is greater than 1, and or decreasing. Okay, if this a is greater than 1, yes, a is between 0 and 1. Okay, so the inverse exists. Okay, and so the inverse exists. So how do you denote the inverse? Okay, so we are going to denote it by this function. Okay, so that means the inverse function. Okay. Now we always use the input variable, use x as the input variable. Okay, and so how do we define the inverse function in traditional way, right? It's we do this, how to find it even, right? This is how do we do that? You let a to be y to be a to the x, right? Then you just like pretend to solve for x. So x is going to be natural log of a with, that's right. That's a relationship. Okay, you solve for x, and in terms of y, then how to express that? So you use a log that was base a. But so then you get a function, but in variable of y. But traditionally, we always use x as the input variable. So this you get the function natural log of log of x in with base fa. So you can switch the variable, and you can get this. All right. Now, so how do we draw the graph? How to draw the graph for that function? We want to, So those two equations are equivalent. Okay, y equals a to the x is actually the same as x equals log of y with respect to a. So was base a. So the in case a is greater than 1. Okay, let's give an example. Right. So this is a graph y equals a to the x. This is also the graph y equals x equals log of y with base a. So because those two equations are the same. And then you draw the line, draw the middle line, right? So this is a line y equals x. Okay. Now, how can I draw the graph of this? The relationship between those two equations, right? You switch, interchange the variable. Interchange x and y, right? That's why, that's the relationship. So the graph of those two, different equations, okay, are symmetric about the line y equals x. So the graph, yeah, the graph is going to be this. Okay, it's a symmetric, so this is a graph y equals log of x. Okay, what I want to say that the graph of y equals natural log of x is symmetric about the line y is symmetric to, okay, symmetric to the line. Okay. Yeah. Is symmetric to x. Okay, you know, those two equations are just interchangeable, okay, with respect to the line y equals x. Okay. Was it with respect to line y equals x? Right. Right. That, you know, that's what we learned before. Okay. So x equals log of L of y is just same as y equals a to x. Okay. So this is the same as y equals a to x, just in different form, you know. All right. So that is a graph. So if a is greater than 1, then the natural log is, the log function is also increasing, right? And you can see that the domain for the function is from negative infinity to positive infinity, right? That for the range of the function is from 0 to infinity, right? Then the domain of the inverse will be from 0 to infinity, and the range of the inverse is going from negative infinity to positive infinity. You can see that from the graph, okay? And the range, you know, goes from negative infinity to positive infinity. So this is an exponential function, and its inverse. Okay. And what is this number here? Okay, this number actually is 1. It's symmetric. Okay, so in other words, log, you know, a to the 1 is a, right? Right? Yeah, a to the 1 is a, and the a to the 0 is 1. So how can I express this? The same as okay. So this will be natural log of a and 1. It's going to be 0. All right. Now, we also have to look at some formulas. The formula here, you see, I'm trying to list the formula for the log. So log was base a, okay, x times y is going to be, it's a separate, okay? And there's a corresponding formula here is, yeah, it's going to be e to the alpha times e to the beta is going to be e to the alpha plus beta. Okay. Then you have this. Okay. The corresponding formula here, e to the alpha over e to the beta is going to be e to the alpha minus beta. Okay. Then you have a to the x to the power k, the k to the natural log of a to the x. All right. Then you have the corresponding formula here. Okay. So those are the formulas we should know about the log function and exponential function. All right. Now, by the definition of our inverse, right? Remember, f negative x should be equal to x, and right, the inverse. This also should be x, right? Now, sometimes we use a y variable here. Doesn't matter, the variable is not important here. So sometimes we put y here, you know, because originally, you know, the original variable for the inverse function is y, okay? So how do we translate this relationship to the exponential and log function? Well, this is going to be a to the x is going to be x here, okay? And this is going to be a to the natural log of a y, that's y. So this is in the power position, okay? So because they're inverse to each other, okay? They're inverse to each other. Okay. And most important thing is the natural log ln x is defined to be log with base e to the x. Okay, so therefore you have, when you have this identity, you have this identity. Okay, because they're inverse to each other. Okay, so let's practice. Let's do some exercise to get familiar with the examples. Yeah, I'm familiar with a log function. The first example I want to look at is simplifying this. Okay. All right, how do you simplify? First of all, I know that 8 is 2 cubed, okay? And then I use a third equation, or just use that one, or use this, right? Even you can use this one, you can get the answer right away, right? So it's just equals 3. Or you can do one more step. Log of 2 with base 2 is going to be 1, so it's just 3. Okay, now how about I switch it? Okay. If I want to switch it, then I cannot change 8, but I can change it 2. 2 is 8 to the 1/3. So therefore it's going to be 1/3, and then it's going to be 1/3. Okay, right? Similar. Right. The next one. Let's maybe do one more complicated one. We have 3 terms. Okay, we're trying to simplify. You cannot simplify each individual, but combined maybe. Okay. According to the formula, the first 2 terms, it's different with the same base. So that would be 60 divided by 3. Okay. Then this again is the difference, right? So it will be 60 divided by 3 divided by 5. And the 3 times 5 is 15. So it will be 60 divided by 15. 15 is going to be 4, right? 60 divided by 15 is 4. Okay. Then almost done. Like 4 is going to be what? 4 is going to be, how can you find the relation between 4 and the 8, right? Right, 4 to a certain power is going to be 8. Okay, be very careful, okay? 4 is going to be 2 squared. 8 is going to be 2 cubed. Okay, how can I relate them, right? So I want to write 4 equals 8 something. I think, yeah, I think, yeah, certain power, right? So what I'm going to do is I'm going to do like this, 2 square, right? And then what is 2 square? What is 2? 2 is 8 to the 1/3. So that's why I get 8 to the 2/3. Okay. So therefore, 8 to the 2/3. Then you got 2/3 log A, and that's 2/3. Okay. After simplifying, you got 2/3. But now, on the calculator, right, you probably don't see the button log with base 8. Okay, how to estimate? Yeah, question is how to estimate using calculator, right? Now, the calculator can design that way. You can enter two numbers, 60 and 8, right? Log. Some calculator does have this function. But some calculator only you can see is the nature log. Okay. Yeah. There's a very important formula. Okay. Very important formula. It says that natural log B with base 8 is going to be, you can use any base. Yeah, let's use X here instead of B. Or you can, yeah, put the X here. I can use any base. Okay. In particular, you can let B to be E. Then you can natural log X, natural log Y. That is weird, right? Okay, so once you accept, if you accept this formula, then that's much easier to estimate this, to even calculate this one. Why? Because this is going to be natural log of 4, natural log of 8, right? Okay, then so what? Well, natural log of 4 is 4 is 2 square. 8 is a 2 cube. So you will get 2 natural log of 2, 3 natural log of 2. So natural log of 2, I don't need to know what is the value. So you get 2/3. So you got 2/3. Okay, right? That's pretty quick way to do. Yes, I said at the very beginning. You can use, you can look at textbook. You can use a calculator when you take the quiz. Okay. What you cannot do is ask somebody else to do the quiz for you. Okay. And right now, probably it's harder to avoid that, but possibly we're going to adapt the new system. It's called the Mobius or Maple TA, and you do the homework and the quizzes online into the information, into the data. So I would collect this automatically. So it's much harder to work on that with somebody else together. Okay. No quiz today. That was a mistake. Okay. So next problem I want to discuss is the following. I'm trying to solve the equation. No, not this time. This time it's I don't have even time. I'm going to go through a training session tomorrow, and then I know how to set up. Okay. Yeah, solve this equation for x, of course, for x. Okay. So to solve this equation, there are a couple ways to do. One is, you know, e to the x equals y, right? It's the same as x equals natural log of y, right? So if you know that, then you see that 3x plus 1 should be equal to natural log of 5. And 3x equals, and how to express, how to move 1 to the right hand side. Don't write like 3, 5 minus 1. So it looks like a 5 minus 1 inside the natural log. If you have to write it this way, you have to put the parenthesis around the 5. So make sure it's separate, okay? Then x is going to be natural log of 5 minus 1 divided by 3. If you write in this form, there's no need to put the parenthesis around the natural log of 5. Okay, that's where avoid making mistakes. Now, another method I'm trying to show you is I use a formula natural log of e to the x equals x. Okay, so here's using this. Okay, how can I do that? Well, e to the 3x plus 1 equals 5, right? So what I'm going to do, I'm put a natural log on both sides. Okay, now on the left hand side, natural log, once natural log meets e, it's gone. So just 3x plus 1. So you end up with the same equation. Okay, then from here you get natural log of 5 minus 1 divided by 3. Yeah, I like the second method. Okay, yeah, you know, another equation you can use is sometimes you use this e. Okay, yeah, for example, natural log of 2x plus 1 equals 2 minus natural log of x. Right, how to solve this equation? Yeah, there are many ways to solve this equation. Okay. Well, I can move this to the left, right? Right, and then combine them. Okay, so then you get very similar, right? Okay. So natural log of x equals y, right? This is the same as x equals e to the y. Do you agree? Or natural y equals x, right? And then y equals e to the x, the same. Y equals e to the x. Okay, so 2x plus 1 times x equals e squared. Right? Equals e squared. Then you get a quadratic equation. Okay, then of course you have to use a quadratic formula to solve the problem. So x equals 3 times 2 here, negative b plus minus b squared minus 4ac. Okay, and I get negative 1 plus minus 1 plus 8e squared and 4. Now, so you get two solutions. Double check, okay? Double check whether both are solutions. One is a positive, one other one is negative. This is a negative. The second one is positive. Okay, why it's positive? Because the square root of 1 plus 8e squared is greater than 1. So minus 1 is positive, right? And then you go back to the equation again. This product is always positive, but before you get to this product, those two terms should be defined. So natural log x will be not defined if x is negative. So that's why the only possible solution is, okay, but you still have to check whether so this guarantee x is positive, but you also have to guarantee 2x plus 1 is positive. But I think 2x plus 1 is positive is clear. Why? Because if x is positive, right, and the 2x plus 1 is e squared is positive, so this implies 2x plus 1 is positive. Don't worry about that, right? You don't need to check it directly because x satisfies this equation. X is positive, 2x plus 1 definitely is positive. Okay, so this is a solution. Yeah. So this will be the answer. All right. Yeah. Okay, so let's solve the next equation. Natural log of x and natural log of x minus 1 equals 1. It's a similar here. Right, at the end you have to double check the answer. Okay, we use the same idea to solve the problem. So you have to multiply, yeah. So you get 1, right? Then you can compare both sides, and clearly x times x minus 1 equals what? Equals e, or 1 or 0. Okay, if you're not sure what is that, then you look at this. Natural log of y equals x. It's the same as y equals e to the x, okay? That's what, how do we define the natural log? Okay, so that's why this is going to be e to the x. X is 1, so e to the 1. Okay. Right, x squared minus x equal e, then you move e to the left-hand side, so you get a quadratic equation, and you solve for the quadratic equation using quadratic formula plus 4e. Okay, I just write down answer. And one of them is negative, so the solution, the two solutions, the answer will be x should be equal to the positive one. Okay, the other one is negative because when choosing negative sign, the second term is larger than the first term, it's negative. So this is the answer. Right. Yeah, this section we just trying to get familiar with the natural log. You know, the next section we're talking about the derivative of the natural log. Okay. So let's take a look at the next equation. E to the x, whoa, equals 10. Okay. Yeah. Right. So again, we need there are a couple ways to do. Okay. I prefer not to record the definitions and natural log. Okay. So the definition, y equals e to the x, equivalent x equals natural log of y, right? Another identity you can use is e to the natural log of y equals y, and natural log of e to the x is going to be x, right? So you can use any of them, okay, to solve the problem. Okay, let's use this one to solve it. So that means this part should be equal to natural log of, natural log of 10, right? And again, uses this identity, x should be equal to natural log of 10. Done. Okay, that's the first method. Second method, I want to use this to get to the formula. So what I'm going to do is e to the natural log of 10, right? What I'm doing is I'm going to put natural log on both sides first. And this, by above the formula, this should be equal to that part, right? Natural log and e, they'll be gone. So e to the x, right? And then you still put the natural log on both sides. And this side is just x. You see? So different approaches get end up with the same answer. Okay, all you have to repeatedly put natural log on both sides. All right, now I'm going to look at the following problem to find the inverse. Given f of x equals natural log of 2 plus natural log of x. Okay. Question 1. Find the domain of f. Question 2. Find the inverse if it exists. Okay. All right. Right. Yeah, you can look at it, try how to do this. Think about it. You have to know what is the domain of natural log, right? First. Right, so the natural log function looks like that. And this is the 1. Right, so y equals natural log of x. All right, so to solve the first problem, by definition, right, domain of f is going to be the x. Yeah, that's first step we can write, the x, for which this is defined, right? Okay, when the f of x is defined, look at the picture, when the natural log is defined, right? So you have to solve this in coordinate, okay? So that means natural log of x should be greater than -2. And natural log of x is greater than -2. How to solve for x, right? You put e under both sides. And this side is just x. Okay. So this is the inequality, the final inequality. So the domain of f is e to the -2 and the positive infinity. That's the domain. Okay. Now, why this function has inverse? I think the function has inverse because this function is increasing. Yeah, this function is increasing. Why it's increasing? As x increases, natural log of x increases, right? Okay. Natural log of x increases. So does 2 plus natural log of x. Right? Then, if we put into the natural log of 2 plus, right, increases. That's why step by step, you know. Okay. So the inverse exists. So this implies the inverse exists. Now, sometimes you're not able to find the formula for the inverse, but at least they still can tell the inverse exists. It's just the, you know, it's just a special number, a special function, right? Which cannot be expressed in terms of element function. But sometimes you can, okay? For example, yeah, in this case, you set equation. Let's solve for x, okay? And once you solve for x, you will get the inverse function, right? Remember, right? Y equals f of x. If we're able to solve for x, then you get the formula for the inverse function in the variable y. Right? Right, so we do that. How can I get rid of nature, right? You put the y, put the e under that. Okay? The left-hand side, the right-hand side, sorry. The right-hand side, this 2 constant, right? So it's 2 plus natural log of x. Okay, then next step is move 2 to the left-hand side. That's y, you know, that's very natural because you want to find the x. You isolate the term containing x. So you have to move 2 to the left-hand side. All right. So every step, you know, in calculus, you know, it involves algebra. You know, if you have a good algebra skill, you will not make mistakes. Okay, that is why, you know, if you're math teaching in middle school and high school, you are required to take math courses every 5 years, I think, to renew the license. So when you go through the calculus courses, you probably don't need to teach calculus in high school, but all this kind of practice, again, will help you to improve the algebra skill, okay? Some teachers feel good enough, you know, then they're allowed to teach AP calculus in high school. Yeah. By the way, yes, if you are able to pass AP calculus in high school, then you don't need to take this course here. So this is the best place in high school to substitution. Okay. If you take many AP courses in high school, you don't need to spend 4 years in college to get a bachelor's degree. Right? So now you put E under that. Right? So you got e to the natural x, it's going to x. Okay, so this is our inverse function. Okay, so the inverse function is e to the y minus 2. All right, that's it. And if you want to change the variable, then you change the variable. Okay, so this is the answer. All right, our next problem, g of x equals natural log of 4 x plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12 plus 13 plus 14 plus 15 plus 16 plus 17 plus 18 plus 19 plus 20 plus 21 plus 22 plus 23 plus 24 plus 25 plus 26 plus 27 plus 28 plus 29 plus 30 plus 31 plus 32 plus 33 plus 34 plus 35 plus 36 plus 37 plus 38 plus 39 plus 40 plus 41 plus 42 plus 43 plus 44 plus 45 plus 46 plus 47 plus 48 plus 49 plus 50 plus 51 plus 52 plus 53 plus 54 plus 55 plus 56 plus 57 plus 58 plus 59 plus 60 plus 61 plus 62 plus 63 plus 64 plus 65 plus 66 plus 67 plus 68 plus 69 plus 70 plus 71 plus 72 plus 73 plus 74 plus 75 plus 76 plus 77 plus 78 plus 79 plus 80 plus 81 plus 82 plus 83 plus 84 plus 85 plus 86 plus 87 plus 88 plus 89 plus 90 plus 91 plus 92 plus cube plus 2, 1. Okay. What do we have to do? We have to find the inverse if it exists. Okay. Now I think it's the function is the increasing function. Okay. So the inverse exists. Why it's increasing function? The log function is increasing function. As x increases, x cubed plus 2 increases. So if put into the log, this will be increasing function. Okay, and the inverse exists. So let's try to solve it. To find this inverse formula. Okay. So you set y to be g of x, right? You're supposed to get x, and then you get the inverse function, right? So can you try this by yourself? Okay. Can you solve for x? Yeah. Go ahead, please. All right. I hope we got it, right? Let's try together. Okay. So y equals this, right? So that means x cubed plus 2 equals 4 to the y, right? I hope you know this part, right? Then x cubed equals 4 to the y minus 2. You can always solve for x, right? There's 4 to the y minus 2 to the 1/3. So this is our inverse function, but in the variable y. Then you can write down this formula. Okay. All right, that's it. The next problem is natural log of x plus square root of x squared plus 1. Okay, let's try this. Find this. So find the inverse if it exists. Okay. Please go ahead to work on that. Okay. We should have plenty of time. So I hope you can get an answer within 1 minute. Okay. All right, so let's finish it. Okay, I hope everybody get the answer. All right, so step one, right? You set this, then you try to get x, right? And the way to do is try, get rid of the natural log. So you can put e under both sides. Then the right-hand side, the natural log is gone. You see? Okay, great. What is the next step? We don't like the square root. Okay, that's why this is a fact. We don't like the square root. How can we get rid of square root? The next step. Well, the way you do is you have to move x temporarily, right? And to the left-hand side. It's like some kind of compute games. You want to go through that part and have to move that as a piece away. Okay, then you square it, right? Then you get x squared plus 1. Okay. Not too bad, actually. You will get y squared 2y minus 2x e to the y plus x squared equals x squared plus 1. All right. Well, I thought that I'm going to get a quadratic equation. Actually, it turns out to be not much better. Just one equation, linear equation in x variable. All right, only this term has x there. If I have negative sign, I can move to the right-hand side. Okay, and then move x1 to the left-hand side, 2x e to the y. Finally, I solve for x. X is going to be 2e to the y, e to the 2y minus 1, right? This is actually a pretty nice function. Okay, you can see I divide the numerator e to the 2y divided by e to the y is going to be just y. And minus e1 divided by e to the y is negative y. See, are you familiar with this function? Yeah, this, okay, anyway, this is going to be the inverse. Okay, this is going to be the inverse. Formula for the inverse. And actually, this is denoted by hyperbolic sine y. Because it's behavior like sine x, but it's hyperbolic function in some sense. Right. Right. Now, conversely, if you know the hyperbolic function, and the inverse will be the natural log of that function. Okay, so the hyperbolic sine y is not a brand new function. It is defined by the exponential function, and its inverse is also not a brand new function, right? So here, yeah, this is going to be e to the x minus e to the negative x. Right, so we got this, right? So that's it, great. I hope you get this too, right? Yeah. All right, our next problem, I'm going to solve the inequality. Okay, solve this inequality. Solving inequality is similar to solving equation, in a similar way. Okay, but just a little bit more careful when you multiply the inequality by a negative number. Okay. So step one, you have to isolate the term containing x. Okay, I can do that. Move 1 to the right hand side, so 3 minus 1 is 2. Okay. Now be careful, right? Now you have to divide both sides by, you can divide by -2. When divide by -2, change the inequality, direction inequality. Yeah, then this is a natural x greater than 1. So how can I get x? I can put e under both sides, and this side is just x. Okay, so that is the answer. Okay, x greater than e to the -1. Okay, right, step by step. Yeah, it's very similar to solving equation, but be careful when you multiply or divide by negative number. You change the direction of the inequality. If you don't, if you forget, you will get totally different answers. But still, at the end, when you look at the answer, you ask yourself, it's reasonable. Suppose you forgot, change the sign, change the direction of inequality. X is like less than e to the -1. You look at, is this going to be a solution? X is less than some number. 0 is also less than this number. But if you plug 0 into the original equation, the natural log of 0 is non-defined. So you have to go back to look at the inequality. Okay, look at your solution. Then you find, oh, I forgot to change the direction inequality. Okay, so always, if possible, look at the answer and look at the original equation. Ask yourself, is this a reasonable answer, right? Okay. All right. So now here's going to be the problem by exponential function. If e to the x over y is going to be x minus 1, find the derivative of y with respect to implicit differentiation. Okay, implicit differentiation. Implicit differentiation. Okay, how do you do that? Well, just like a chain rule, okay? Derivative of x, e to the u should be equal to e to the u du of dx, right? If you use something here, depends on x, okay? So what I'm gonna do is put okay, put this also, okay? So this side is x over y, and the derivative of x over y. And here's derivative x with respect is 1, derivative y with respect to x. Okay. And here I have to use a chain rule, a quotient rule, right? So the derivative of x with respect to x is 1 here, minus x and dy with dx, right? That's the chain rule, right? The quotient rule, you differentiate the numerator and denominator separate. Then you look at all the terms. You try to find, then you try to find the derivative, right? Step by step. I'm going to rewrite this again. Y over this is 1y. Here's x over y squared. Yeah. Just one more step. Then I multiply this out. Then I have a okay. So this term contains x. Right, so I'm going to move this term to the right hand side, move the other term to the left. So it should be extremely careful when you do this, don't miss any terms. So this will be dy over dx minus x squared y squared e to the x and y. dy over dx. The right-hand side is 1 minus 1 of y e to the x to y. Okay, finally, I can solve for the derivative, okay? So the derivative I see I make mistakes when I copy it. You see, it looks pretty strange, I squared it. That's why, it's easy to make mistakes. Okay, so that is answer. It's pretty complicated, unfortunately. So that's the derivative. But you know that you needed to be patient, careful when you work on this problem. Okay. Our last problem I want to discuss is to find the derivative of log was base 1/2 x. Wow, I say I never know that, right? How to find the derivative of this? Okay. Right? How to find the derivatives? But you needed to know how to find it. Yeah, where this problem is the topic next time. Okay, so derivative of e to the x is going to be e to the x, right? How to find the derivative of natural log of x equals what? Oops, my file is gone. Yeah, just a second. Last. Oops. Okay, it's coming back. Yeah. All right. So we want to find the derivative of this, but at least you should know the derivative of natural log of x, right? We get some ideas, right? How to do that? Well, you can do this e to the natural log of x equals x, right? So you differentiate both sides. You differentiate both sides with respect to x. The left-hand side, this is a composite of two functions, so it's going to be e to the natural x, the derivative of natural log x. The right-hand side is just 1. But e to the natural x is just x. Okay, so you will get the derivative of natural log x equals 1 of x. Wow, this is a very interesting equation. Okay, then you are able to do the find the derivative of this, because this one is going to be natural log x, natural log of 1/2. So when you differentiate that, it just all you have to do differentiate natural log x. So derivative of a log function with respect to an arbitrary basis is going to be the derivative of natural log x, right? It's just 1 of x, natural log of 1/2. Okay, so we solve this problem. That's it. And yeah, next class will be on Wednesday.